In this video, we'll look at building a new object using the processor object definition. And so if we look at the new model ribbon, we can see that the processor is a subset or a submenu from the fixed class. And essentially what the processor is it's a starting point to build a model from the ground up. So it helps you out a little bit, fills in a couple of the details, but by and large you're building a model from scratch. And as you'll see, building the model from scratch gives us a tremendous amount of flexibility, but we also have to deal with many details of the model. So let's start out with our blank model. And what I'm going to do is go to the project home like we did before with new model, except this time I'm going to pick up processor. So we do that, and we can now select our processor object, which we just created, and we don't see anything. There's nothing in the facility view, so it's essentially just a blank model. But if we go to the processes, we will see that there is what's called the main process, and that process is triggered by the event processing entered. And so we go to our definitions and see that the processor object has a processing station. Recall, a station is a location where entities can reside. And so when the entities enter the object, they enter the processing station, and we simply have an in transfer step transferring into processing and a transfer out. And so if we look at the external view, we have our input node and our output node as we did before. The input node is simply mapped to the input station. And so unlike before when we built the hierarchical model where the input node was mapped to one of the nodes in the facility view, we don't have nodes in the facility view. And so for this model, the input location is simply a station. And so when an entity hits the node, it immediately transfers to the station, assuming their station capacity, and the processing.entered event is fired, causing the process to occur. So if we go back to our model and now place one of these, so let's place our processing object, or processor object here, and we'll just grab a source and a sink as we've done many times before, and I'll just connect these guys up with paths, source to the processor, processor to the sink. And now when we run our model, we can see entities arriving and going from the source and going through the processor, but it doesn't look like anything's happening. So let's fast forward and we'll run for our default 24 hours. And now if we look at our results, we see that we do have a processor object type, the one we just created, and we're simply tracking two things, the number entered and the number exited. And so if we go back and look at let's stop the model here, and let's go back and look at our processor, and we see why nothing's happening. Well, because we haven't told it to do anything. When an entity arrives through the input node, it simply ends the transfer into the processing station, and then simply immediately transfers out to the output node. So when we place that in our model, we have entities arriving, and then they're immediately transferred to the output node. So we probably are going to want something to happen in our process, and so what we would do is we would add that logic right in this area. So let's do that. Let's add a delay. We'll simply go and delay. And then for the delay time, I'm going to create a reference property. Call it processing time. And then as before, we can go to our definitions, properties, and here's our processing time. And I'm going to go to the category and say I want this processing time to show up in the process logic. And so now if we go back to our model, let's look here, and we see we have this processing time property right here. And so what we're going to do is we're going to set a processing time. So let's just use what Simio generally uses for a default, random, triangular, and then we will have the minimum mode and maximum of 0.1, 0.2, 0.3. And then we'll change it from hours to minutes. And so now when we run, we can see that entities arrive, they go into the processing station, they're delayed for a random time, and then they depart. So again, let's fast forward to the end of our 24-hour run and look at the results. And now we can see, in addition to our throughput, we also have station information. So we have the number in station and the time in station for our processing station. Now, if we go back, when we watch the model run, one thing we should notice immediately is that we're not enforcing any capacity. So when an entity arrives, it immediately is transferred into the processing station and then goes through its time delay, but we're not maintaining any capacity of the processor, which we typically see, for example, when we have the server. So to do that, we can go back, we can stop the model, go back and look at our processor, and if we look at the processing station, we note over here that the initial capacity is infinity. So what I'm going to do is change this to 1, simply saying that I want to limit the capacity of the station to 1. Then I'm going to go back to our model, and I'm going to make one small change here. I'm going to go to path where entities enter the processor, and I'm going to set the allow processing to false. And you'll see why we want to do that here in just a second. So now I've specified that the station has capacity 1. So when we run the model, now what we'll see is that we will never have more than one entity in the processing station because we've limited its capacity, and we can see that entities don't leave the path. And so that's why we set the passing to false, so that we could see the entities line up. So in this case, the path is essentially acting as an input buffer because our basic processor object doesn't have an input buffer. It simply transfers entities from the network into the station. If there's no capacity in the station, then the entities just wait in order to do the transfer. So again, let's fast forward our run to the end of our 24-hour period and then look at the results. And when we look at our processor object now, we can see that we have an entry queue that provides information about entities that are waiting to enter the object. And so the entry queue is for the processing station of the processor object. And so go back to the facility, and these are the entities that are along the path and are also in the entry queue. Okay, so let's continue enhancing our model, our object, the processor object. And so let's go back to the process. And what we're going to do next is we're going to add a seize step right here before the delay. And what I want to seize is the parent object. And so let's seize under object type, the parent object. And then after the delay, we'll simply release the same object. And so we go back and add, and I want to release the parent object. And so now we see what happens when an entity is transferred into the station. As soon as it enters, it then seizes the parent object, goes through a delay, and then releases the parent object. So if we go back to our model and now run, and let's fast forward again, and here we are at our 24-hour state. And if we look at the results, now we see additional information about our processor. In particular, we see information about the resource. So we get the scheduled utilization, the units allocated, and so on, the same information that we see by default about all Simio resources. And so if we go back, we can see what's happening, or we can see how this happens. Let's go to the processor, processes, and recall we have the seize and the release, and on the seize we said that we wanted to seize the parent object, or that's the object type that we want. So if we go to our processor definitions and we look at the properties, we can see that we have the resource object set for true. So this is by default. When we created the new object, Simio interprets all new objects, or all objects with this resource object property set to true, as seizable objects, and then provides the corresponding information in the results. And so by adding the seize and release, we simply are capturing that additional performance information. Okay, so the last thing I want to do is I want to make one small change here. I'm going to go back to my definitions and my elements, and the processing, where we had the processing capacity was initially infinity and we set it to 1. I'm simply going to set it to the property initial capacity. And so initial capacity already existed. It was inherited. And so when we go back to our model facility now, we can see that we have that initial capacity. And so we can change that. Let's change it to 2, for example, and then the station will inherit that. And so instead of having to go back to our processor definition to make that change, we simply specify that as a property and let the user change on the individual instances. Okay, and one minor thing that I want to do to clean things up a little bit is if we look at our process logic, we don't have any mechanism for different capacity types. The ranking rule and the dynamic selection rule all have no meaning for our processor object. So let's go back and make those not visible. So we go to the processor, properties. Those are all inherited properties. And so I can go and find the ones I'm interested in, like capacity type, and I'm just going to set its visibility to false. And ranking rule, capacity type, ranking rule, also false, and dynamic selection rule, we'll make that one false also. And so now when we go back to our model, we can see that we have only those properties that we actually use. So we have the capacity of the processor, and then we have the processing time. And for the last part of this video, let's go back to our processor and look at the external view. And again, there's no need to keep the default external view. So for example, I could delete that and delete the gray box and put, a different color box like we did for our tandem queuing model. I could import a symbol from the 3D warehouse. I could use one of the existing symbols, so I'm not limited to having to drawing the symbols myself. Now note when I do this, so I've changed the external view and I go back to my model and the external view updated. But it's not exactly the same. So in particular, if I go back to my processor, you note that we moved the queue, the processing contents queue, down closer when I made the box smaller. But in our model, the box changed, but the queue didn't. Well, that's because when you update an object, when you update the object definition or the object view, some things update automatically where you've placed instances of that object and others don't. It's a bit complicated to know what does and doesn't, but basically what it comes down to is anything that the user can change does not automatically get updated, and anything that the user can't change does get automatically updated. So worst case, we can always delete. So for example, I can delete the processor and then go back and place it, and when I do that, it has the view, the updated external view. So let's do that, and I'll go and then make the modifications that we had before. So we'll just make sure that this path allows passing, or doesn't allow passing, sorry. And then we'll have our processing time of random, triangular, and then we have our point 1, point 1, point 2, point 3, and then we'll change that back to minutes. And so now we have updated the external view and then replaced the processor. So now that we have the processor object, we could place additional ones. So I could again go and place another processor in parallel here. So we can do that, and we'll just let the entities go randomly between 1 or 2. And with our second processor, when we placed it, note that we inherited the initial capacity of 1, but we didn't have a processing time. So this time, let's just make this random exponential 0.2. And change that to minutes. So we have our triangular on the top process, we have exponential on the bottom process, and then if we wanted to, we could make entities arrive faster. Let's just make the arrival time 0.15, and so on. And so we can see when we use the process object definition to create our object, what it basically does is gives us the processing station automatically, and then it creates a process that is triggered by entity entering the process station. Finally, it adds the input and output nodes. So the processor object pre-populates our new object with the processing station, the single main process, and the two input and output nodes. And then it's up to you as the object designer to incorporate the logic corresponding to the specific object you're building.